Hey pre-calc, welcome back. Our objective today is going to be to graph equations of circles and ellipses. And I've got the checklist on the screen. You know what to do from here. Just a little reminder of conic sections. Again, conic sections are a family of curves formed by the intersection of a double right cone and a plane. And we've looked at the parabola so far, right? And today we're going to look at the circle as well as the ellipse. So let's take a look at the one you are probably familiar with already. A circle is a set of all points in a plane that are equidistant from a given point called the center of the circle, right? So let's go ahead and derive the equation of a circle. It stems directly from distance formula, right? So take a look. If I grab any point on the circle, let's call it xy. And then let's find its distance from the center. So applying the distance formula, I would have the square root of the quantity x minus h squared plus y minus k squared, right? That's the distance between those 2 points. And I can tell from my picture that that distance is always going to be the same. It's going to be whatever the length of the radius is, which is r, okay? So if I square both sides, I get x minus h quantity squared plus y minus k quantity squared equals r squared. So this is our standard form of the equation of a circle centered at hk with radius r. Do notice that in your formula, your r is squared. All right, I'll press on your screen so you can copy whatever you need. All right, let's try one together. I'm going to force another pause on your screen. Go ahead and copy the equation, and then we will determine the center and radius together. Okay, we are back. So first thing I want you to notice is that your x's and y's are kind of tangled up together. So let's go ahead and separate them out. Let's list our x's first, leave a little bit of space, list our y's first, leave a little bit of space, and then move any constant terms over to the right-hand side, okay? All right, so let's see what we have here. We've got x squared plus 14x, going to leave a little bit of space. Now collect your y terms, y squared plus 2y, leave a little bit of space. And then my constant term, I'm going to bring it over to the right side, so that makes it negative 41. All right, so now let's go ahead and complete the square for the x's and the y's separately. So what would you like to add right here to complete the square? 49, right? Half of 14 is 7, 7 squared is 49. But what I do to one side, I've got to do to the other side. And then let's do the same thing for the y's. So what do you want to add here to complete the square for the y's? 1. Yeah, half of 2 is 1, 1 squared is 1. And what I do to one side, I've got to do to the other, okay? So we've got, now we can factor, right? We've got x plus 7 quantity squared plus y plus 1 quantity squared equals 9, right? Good. Okay, so center is going to be negative 7, negative 1, and the radius will be the square root of 9, which is 3. All right, let's do this one together. Or start it out, at least it says the center is 0, 5, and a point on the circle is 3, 9. We want to use the given information to write the equation of the circle in standard form. So 0, 5, let's plot a little bit here. 0, 5, and then a point on the circle is 3, 9. Right there, right? So we know the center, we know HK, all we need to find is R, which is going to be the distance between those 2 points, right? So I'm let you find R, see if you can get it in standard form, and then we'll check our answers. All right, I've got the answer on the screen. Pause if you need to correct anything. Okay, so that was something we're probably already fairly familiar with. Now let's look at an ellipse. Ellipse is defined as a set of all points in a plane such that the sum of the distances from 2 fixed points called foci, so that's the plural of focus, is a constant. So let me show you a great little YouTube clip to kind of make this more concrete. So I think this was made in like the 90s, but it works, so enjoy the music. So those two toothpicks are foci, and then you can see the sum of the two distances will be constant. And this is going to create a perfect ellipse for us. All right, so I want you to have your ellipse notes that I gave you in front of you so that we can kind of make sense of those general equations. So notice here, we've got kind of some new terms, right? Again, instead of one focus like you did with a parabola, you now have two foci, and those are the two fixed points. And then this distance plus this distance, okay, is going to be constant. And when you make that, the sum of those two distances constant, you create this perfect ellipse, okay? So notice your equations there, and let's kind of make sense of that, like A, B, and C. So you're going to start with your center, and then you are going to add A and subtract A to get to your vertices, which is the plural of vertex, okay? So that is your longer end, okay? Which this one, in this case, would say is opening horizontally, right? So your major axis is horizontal. Your minor axis is the shorter one, okay? So that is when you're going to start from your center and add and subtract B, okay? That's how you get to your co-vertices. So those are the ends of your minor axis, all right? And then to get to your foci, you are going you're going to add and subtract C from your center. Now notice C is not anywhere in your equation, right? So to get C, look at that where it says Pythagorean relation. You've got A squared equals B squared plus C squared. So once you've got A and your B, you can find C using that equation. So let's practice some together. Will you copy my screen and then we will try this together? Okay, so I've got x squared over 25 plus y squared over 16 equals 1. So my first question for you is, do you think that the major axis here is horizontal or vertically? So do we open more in the x direction or the y direction? Yeah, this is going to have a horizontal major axis because my larger number is under the x, okay? Now, notice that your h and your k are both 0, right? Because you've just got x squared plus y squared. You don't have like x minus 2 quantity squared or anything. So the center here is just going to be 0, 0. Okay, now let's go to our A. Again, take your larger number and take the square root. That's going to be 5. And B, take your smaller number in the denominator, square root, that's going to be 4, okay? So to find, remember my vertices, I start at my center and I add A now and subtract A. Now, do you want to add and subtract that to your x coordinate in the center or your y? And add and subtract it to your x, because remember our major axis was horizontal in this case because 25 is larger than 16 and the 25 is under the x, okay? So I am going to add 5 to the x-coordinate of the center and subtract 5, okay? You can also write this as plus or minus 5 comma 0, okay? So my vertices will be at plus or minus 5 on the x-axis. Your co-vertices, you're going to take your B, and now you're going to add and subtract that to the y-coordinate of your center. So that's going to be 0 comma plus or minus 4, okay? So here and here, and now I can draw my ellipse, right? So I've got something like that, okay? Now my foci, how do we find the foci? We need that Pythagorean relation of a squared equals b squared plus c squared, okay? So a squared was 25, b squared was 16. I'm trying to find c squared, okay? So, sorry. 25 minus 16 is going to be 9, right? 3, 4, 5. All right, so I want to add and subtract 3, right? And again, that's going to be on your major axis. So again, your foci will be on the x-axis. So this is a horizontal. So there and there. Okay. So this will be plus or minus 3, 0. Okay. And again, why do I care about the foci? So that's the part where if I pick any point on the circle, then the sum of these two distances in yellow, that will be a constant. All right, go ahead and copy my screen and then we'll do this one together. Okay, so you maybe notice this is kind of similar to that first one we did on the circle. All our x's and y's are together, so we're going to start out very similar to how we did this circle. So collect your x's. We've got 9x squared minus 54x, leave a little bit of space, right? And then collect your y's, so plus 4y squared plus 40y, leave a little bit of space. And then we'll have negative 37 on the right-hand side. Okay, now maybe you see a little bit of a problem here, right? Because now we don't have this understood 1 as a leading term on either the x squared or the y squared. So what we'll need to do is factor out the 9 for the x's and the 4 for the y's. So let's do that. I'm going to have 9, and this will leave me with x squared minus 6x plus 4. This will leave me with y squared plus 10y. Okay, so now we can go ahead and complete the square for both the x's and the y's. So what do you want to add here? We want to add 9, right? Half of negative 6 is negative 3, and negative 3 squared is positive 9. Now here's where you have to be really, really careful, because where did you put that 9? You put it inside a parentheses, right? And tied to that parentheses was that factor of 9. So you actually didn't add 9 to the left side. You actually added 9 times 9. You added 81. Okay? So really think about that. That's probably the most common mistake that I see students make. So that's going to be an 81 that we want to add to the other side. Okay, let's complete the square for the y's. So half of 10 is 5. 5 squared is 25. But again, notice that that 25 actually has a factor of 4 in front of it. So I actually added 100. So we need to balance out the sides there. All right, let's go ahead and factor. We've got 9. This will be x minus 3 quantity squared. And then if we do the same for the y's, I have that 4 in front still. And this will be y plus 5 quantity squared equals 144. Okay, now I have one more step. Take a look at that standard form of the ellipse. What do we have on the right side always? We always have a 1, right? And right now we have a 144. So what do you think? How can we get rid of that 144? Let's divide both sides by 144, right? Just be real careful because your left side of the equation actually has two terms. So you've got this term and this term. So think about when you divide, think about how many times 9 goes into 144 and how many times 4 goes into 144. All right, so when I divide here, I've got x minus 3 squared. 9 over 144 reduces to 1 over 16. And then I've got y plus 5 quantity squared. 4 over 144 reduces to 1 over 36. And then 144 over 144 reduces to 1. So now I've got my equation in the format where I can easily grab the information I need. Okay? All right, so let's go from here. The center is going to be positive 3, negative 5. So now for the vertices, we need to decide, is our major axis horizontal or vertical? What do you say? It's going to be vertical because 36 is larger than 16 and 36 is under the y. Okay, so in this case, A is going to be 6 square root of 36 and B is going to be 4 square root of 16. Okay, so what I'm going to do is add and subtract A, come back to the center, and but now we will need to do this to the y coordinate, right? So if I go up 6, we're going to be here, and if I go down 6, we'll be about here. So let's add 6 to the y coordinate, that's going to give me, hold the x, that's going to give me 3, comma 1. Then if you subtract 6 from the y coordinate, you'll be at 3, comma negative 11. Okay, so those are the 2 red points I have there. So now let's do the same thing for the co-vertices. So now you're going to take your b value, which is 4, and you're going to add and subtract those to the x-coordinate of your center. Okay, so now we're going to go left and right. So let's do that. So if I add 4 to the x-coordinate of the center here, that's going to give me 7, hold the negative 5. If I subtract 4, that's going to give me negative 1. Again, hold the negative 5. So if you see here, if I add 4, I'll be here, subtract, go to the left 4, I'll be there. Yeah. So my ellipse looks something like that. Okay, and if I wanted to find the foci, I would need that Pythagorean relation, which is a squared equals b squared plus c squared. Well, a squared is 36, b squared is 16. So c squared is going to be 20, right? 36 minus 16. So c will be square root of 20. And that will be on the major axis. And remember, that was vertical. So I'm just going to come back to my center and add and subtract square root of 20 to the y coordinate. So that's all you need to do there. All right, the last thing I want you to do is just copy what I have boxed here. You don't have to copy the whole page. Go ahead and read it, but just copy the formula and we will talk about why we care about this number more in the future. All right, I'll see you all in class.